Video is the start of Unit 2. Unit 2 talks about expressions, equations, and inequalities. So the first thing that we're going to talk about is expressions, and we're going to talk about how terms can be combined. So the first thing that we need to talk about is what are terms and what are expressions made up of. So it says an expression is a mathematical phrase that can contain variables, okay, numbers, okay. So these numbers, most of the time we call them constants. Sometimes we call them coefficients. We'll talk about the difference in a second. And operations. So the difference between an expression and an equation is an expression does not have an equal sign with it. There's no answer to the problem. It's just some numbers and some letters in an operation, and we get it to where it's as simple as it can possibly go. So it says use the expression below to label the various parts of the expression. Okay, so the easiest part we're going to start is the plus sign. And so this is the operation. Okay, so the operations, it separates each term. So we have one term, we have two terms in this particular expression. Okay, so this is a term. So, and then we know that x, okay, we talked about this before, letters are called variables. So we have two numbers in here, and these two numbers are called different things. So when we have a number that does not have a letter with it, like this 12, okay, we call this a constant. And when we have a number that is attached to a letter, like this -6, it is called a coefficient. Okay? So we have all these different parts of an expression, and they all kind of help us do different things. So it says, what do you notice about the two terms above? Okay? So one is a constant. And then one contains a variable. So it says terms can be classified as like or unlike. Like terms must have the same variable and the same base. Okay. We also need to note, you really won't see it on here, but it has to be to the same power. For example, if I have x and I have x squared, just because they both have the same variable, they both have x, they're not like terms because one doesn't have an exponent on it and the other one is raised to the second power. So if I wanted them to be like terms, they would have to be the same variable and have the same number exponent attached to it. So what we're going to do on this chart is we're just going to list what the like terms are, okay? So in this particular one, we have 8c and -8c. Okay, because the most important thing is, do they have the same letter attached to it? Okay, it doesn't matter if they have the same number. That has nothing to do with whether or not it's a like term. Is the letter the same? Okay. So in this particular one, 8c and -8c both had a c on it. That makes it a like term. Okay. In this one, we have -12x and we have 12x. Okay. Again, the number doesn't matter, it's the letter. Okay, in this particular one, there are no like terms. None of these have the same letter, so they don't have a like term. Okay. One that I want to talk to you about before I have you practice them on your own is this last one. Okay. And this last one, 0 and -8, they are like terms. Okay. So I said that the letter is what makes it a like term. So both of them have C, both of them have X, okay? But if there's two numbers there and neither of them have a letter, then they have the same letter. They don't have one. So that makes it a like term also. Okay? So I want you to try these 4 on your own. Pause the video. All right, so your like terms in this one, 11G and -7G. Okay? This one is 0.5T and 1.5T. In this problem, we have 1M and we have M. In this one, we actually have 3, 4B, B, and 9B. You can have more than one, like more than 2 numbers be like terms. As long as they have the same letter, they are like terms. There can be multiple. All right. So it says only like terms can be combined. The Robinson family ordered snacks at the state fair. They bought the following drinks: pizza and ice cream cones. Okay, so what I want you to do is for every drink you see, you're going to write the letter D. Okay, for every pizza slice you see, you're going to write the letter P. And for every ice cream cone you see, you're going to write the letter C. So it says write an expression to represent their purchases. So we have P plus P plus D plus D plus C plus P plus C plus P plus P plus D. Okay, so that's a big long expression that we have written out. So now it says simplify the expression by combining like terms. Okay, so how many pizza slices do we see? Okay, we have 1, 2, 3, 4, 5. Okay, so I'm going to write that by saying we have 5P. The next thing that we're going to do is we're going to talk about the drinks. So we have 1, 2, 3 drinks. So we have 2D. I'm sorry, 3D, not 2D. And we add those together. And then the last thing we have is how many ice cream cones we have. We have 2 ice cream cones, so that is 2C. So what this shows me is if I ended up wanting to say, okay, what was the price of everything? I could take the price of a pizza slice. Say the slice of pizza is $2. We would do 5 times 2. Okay, so this coefficient is just telling you how many times the pizza shows up. And then if we want to put in a number to represent the pizza, like the cost, we would put it in there to multiply. Same thing with drinks. If we decided we wanted to talk about how much drinks cost, we could put that in there for the letter D instead. But we can multiply it by the number of times we see drinks. So we are going to do the first 3 together. Actually, we're going to do the first 4 together. First 4. All right. If it helps you out, you can, I highlight my like terms. So I have 7A and I have 8A. Okay, those are my like terms. So I'm going to combine those to get 15A minus 6. Something else that I also do is I do what I call, let's draw a fence post, okay? And that separates into terms so that you know, are you dealing with a negative number or are you dealing with a positive number? So in front of every operation sign that you see, okay? So in front of every subtraction sign and every plus sign, okay, we put a line, and that separates it. So in this particular problem, we have three terms. We have 7a, we have a -6, and we have 8a. Those are three different terms. And then we just put them back together after we combine our like terms. So in this problem, I'm going to put a line in front of our plus sign and our minus sign. So we have three terms again. We have 14b, we have 6b, and we have a -12. So my like terms, 14b and 6b. So 14b plus 6b is 20b. Okay, we have a -12, so I'm just going to write -12. Okay, I use whatever sign it has, that's the operation I use. So if it's -12, when I put it back into my problem, I write -12. Okay, so again, we're going to add our little fence posts here. We're going to put one in front of this plus sign, in front of this plus sign, and in front of this plus sign. Okay, so my like terms, 20c and 10c, those are like terms. Okay, so 20c plus 10c combines to make 30c. Then I have two more like terms. I have 8d and -5d. So we're doing 8 minus 5. 8 minus 5 is 3. It's a positive 3, so I'm going to write plus 3d, okay, because those combine to make positive 3d. So because it's a positive, I used a plus sign to put them together. The reason I wanted to do this one with you is because it's a little bit different. So all of these are like terms, okay? -3d, okay, we're going to draw our little fence posts. -3d plus 8d plus 5d. So if you remember when we were doing adding integers and stuff and adding more than one number together, I start with the ones that have the same sign. So I have -3d and -5d. Those combine together to make 8d. I'm going to write that 8 better. 8d, okay? So we have -8d, and then we bring down our positive 8d. Those two things combine together to make 0. So our answer for that one is 0. All right, so I would like for you to try the next 5 on your own. Pause the video. This combines to make -4e minus 9, -5f plus 6, 8g minus 13, 4h minus 1, and 5.9, make that 9 better, 5.9j minus 5. All right, so you are going to grab the quick check that says, how can terms be combined?